Hi again. In this video, I'm going to talk a little bit more about the atom in regards to atomic number, mass number, isotopes, and what have you. In my last video, I talked about what is in the atom. We have the subatomic particles, proton, neutron, electron, protons and neutrons residing in the nucleus, the electrons in the electron cloud, protons having plus charge, neutrons having no charge, electrons having a negative charge, and the mass of each protons and neutrons, each giving 1 AMU of mass to the atom, and electrons having no AMU mass. So we have the symbols, protons, neutrons, and electrons. And we have the periodic table. And as I said, the protons define the identity of the element. Each element has a specific number. I'll point out some of them right here at the top of this periodic table. For each block, each element has its own number, and that's the atomic number. I'll write that down here. And that's nothing more than the number of protons for that element. So boron is boron because all atoms of boron have just 5 protons. Every carbon atom has 6 protons. If you have an atom with 7 protons, it has to be nitrogen. So the number of protons identifies the atom as a particular element. So we move on to neutrons. And neutrons and protons, the sum of those numbers give rise to isotopes. And basically, an isotope is nothing more than a mass flavor of an atom. Some atoms have different mass flavors, others have very few mass flavors. And as we said in the last video, neutrons stabilize the nucleus of the atom. So there's also certain ratios of protons to neutrons that are stable and that cause that particular atom to exist. And these different ratios obviously give rise to different masses because protons and neutrons both have 1 AMU of mass. So for example, if we have chlorine, chlorine has 2 major isotopes. Chlorine with a mass of 35 AMU and chlorine with a mass of 37 AMU. Well, as we see on the periodic table, chlorine is chlorine because every chlorine has 17 protons. So in chlorine 35, if it already has 17 protons, I'll put that right here. Well, for chlorine 35, if it has 35 total mass units, 17 of those are protons, well then chlorine with a mass of 35 must have 18 neutrons. Chlorine with a mass of 37 must have 20 neutrons. And there is no way to calculate what makes a particular atom stable. You just need to know what isotopes are there. And in this course, we're not going to make you guess what isotopes are in fact stable. We're just going to give you these mass numbers. And that's what I just introduced, mass numbers. It's a sum of protons and neutrons. So we designate the different isotopes by their mass number. And there are 2 ways to show this. Chlorine-35, chlorine-37, or by putting it as a superscript before the elemental symbol. This area here superscript before the elemental symbol is where we put our mass numbers. And in your reading, you'll probably see that the atomic number goes in the subscript in front of the atomic symbol. So having both those numbered there, you can tell chlorine has 17 protons and a total mass number of 35, which means that it should have 18 neutrons here, and in this case, 20 neutrons. Now, before I end this video, I'd just like to touch base on one little aspect of atoms. By definition, atoms must be neutral. So let's think about what gives us charge in the atom. Protons give positive charge, neutrons don't give any charge, but electrons give negative charge. So scrolling back down here, every element on the periodic table must have protons. That defines the element's identity. So if every atom has a certain number of protons, and an atom by definition must be neutral, the number of protons will always equal the number of electrons for an atom of that element. Now, I just want to note that this is just semantics. We're always talking about atoms, but when we're talking about uncharged building blocks of matter, we're talking about them as atoms. Atoms can be charged. We just call them ions. That's our differentiation in terminology between a non-charged atom and a charged atom. And we'll talk about that in a later video. So just for a recap, we have protons in the nucleus. They have a positive charge and a mass of 1. Neutrons in the nucleus, mass of 1, no charge. Electrons in the electron cloud, basically negligible mass, but a negative charge. Every element has its specific atomic number, which is the number of protons. And by definition, an atom will be neutral. So the number of protons must equal the number of electrons in order to make it electrically neutral. And each element has a chance to have mass flavors for that particular element. And this is where the neutrons come in, stabilizing the existence of that atom. And we can differentiate each of those isotopes by their mass number. And we can illustrate that with a dash and the mass number or with the superscript before the symbol.